Hello everyone, welcome to the next lecture on the Laplace transformation. Today I will explain you the 20 more examples for evaluating the integral from 0 to infinity. Myself Dr. Harish Garg. You can simply follow my YouTube channel where there is a playlist of the mathematics 2 and you can find the various lectures related to the Laplace transformation in this playlist. What is the objective of this lecture is, our target is how you can see how you can evaluate this kind of the integral by using the Laplace transformation. So clearly say, if you look about this particular example, can you solve this integration by parts? Can you solve this integration by parts, or can you solve this integration by parts? It is not an easy target for you. So what is the purpose is, whenever you have the function f of t from 0 to infinity, make sure the limit must be from 0 to infinity. If the limit is from 0 to 7, then today's lecture trick is not applicable for you. So what is the rule is, you can find the Laplace transformation of f of t. Fine. So whatever the answer you have obtained, and then you can substitute s will be 0. Fine. So if you get the Laplace transformation of f of t is in terms of the s, and then substitute s is equal to 0, you will get the right answer. This is my tip number 1. Second tip is, whenever you will find the exponential term e raised to power minus a into t f of t. Fine. Whenever you will find this kind of this integration, again make sure the integration must be from 0 to infinity, and e raised to power minus at of this. Again you will find the Laplace transformation of the f of t. You will get f of s, and then you can substitute s is my, compare this is my a. Fine. So you can use either this rule or this rule, both have the same meaning. So look at that. If you look about this example, firstly, because the exponential term present, I can find the Laplace of this quantity. How you can find the Laplace of this? So firstly, I can find the Laplace of the sin t. It is 1 over s square plus 1. Then what is the rule of the multiply by the polynomial? So that means it is minus 1 raised to power 1 first derivative of sin t, or what is the Laplace of the sin t? That is 1 over s square plus 1. So can you find the Laplace derivative? What is the derivative of this? Minus 2s over, you can apply the u over v as well. So this comes to be 2s over s square plus 1 whole square. Now if you want to apply this rule, then you can substitute s is my 3. You can put s is equal to 3, then you will get the right answer. Otherwise, you can, if you want to apply the first rule, I can solve this question by both methods. So I can substitute, put s is equal to exponential, always compare with minus of at. So a will be my 3. So put s is equal to 3 in this case. So therefore integration t e raised to power minus sin t of dt is, I can substitute, this is 6, it's a 9 plus 1 whole square, that is 6 over 100. That means 3 over 50 is the right answer of this problem. Second method is, if you don't want to substitute s, you can find this is the Laplace of this. Now I can find the Laplace of this. How you can apply the Laplace of this? I can use the shifting first theorem. So I have to replace s to be the s minus a, that is a s into s plus 1. So s plus 3 over s plus 3 square plus 1 whole square. Then because we have computed all the Laplace, you can substitute s is equal to 0. So the left hand side becomes my e raised to power minus 3t sin of t into dt. This will be 6 over 100 again. So it is 3 over 50 is my right answer. Look at this, and again exponential term present, I have to find the Laplace of this quantity. How you can find the Laplace of sin square? So because of this sin square, you have to firstly write in terms of linear. So 1 minus cos of 6 into t. How you can find the Laplace of this? Half is a common. Laplace of 1 is 1 over s. Cos will be s over s square plus 36. Fine. So I can take the LCM. So it will be s square will be cancelled out. So it will be my 36 divided by s square plus 36. This is the Laplace of this. Now you have to find the Laplace of small t into sine square. So small t means you have to take 1 times derivative of this answer. So that is a 36. I can see this is 18 over s square plus 36. So this is 18 over s square plus 36. Now you can substitute this. I can say is s square plus 36 square. So this is the first function, s square plus 36 into 0 minus 18. What is the derivative of this? Is a s cube plus 36s. So it is my 3s square plus 36. Fine. Now you can substitute s is equal to 1. So what is the left hand side is 0 to infinity e raised to power minus of t sine square 3t of dt. So I can substitute s is 1. So it is minus, this is a 0. I can substitute s1, it's my 39, 18 into 39 divided by s is 1, it is my 37 square. So your answer will be 18 multiplied by 39 divided by 37 whole square is the right answer. Look at this another one. Again the exponential term present and the limits are from 0 to infinity. Find the Laplace of firstly cos of t. It is s over s square plus 1. Find the Laplace of t square cos of t. Remember always what is the Laplace of t raised to power n? I can write t raised to power n into f of t. It is minus 1 raised to power n, nth derivative of Laplace of f of t. Fine. So it's a minus 1 raised to power 2 second derivative of Laplace of cos. Laplace of cos will be s over s square plus 1. So can you find the second? It's a minus plus. Can you find the second derivative of this? So firstly I can find the first derivative. It's a s square plus 1. It's a s square plus 1 into 1 minus 2s square. So it is d over ds, that is 1 minus s square over s square plus 1 whole square. Fine. Now you can find the second derivative. It will be, what is that derivative? Again u over v. So s square plus 1 raised to power 4. So s square plus 1 square. Derivative of this numerator is minus 2s. 1 minus s square. Derivative of this denominator part. So s square plus 1 into s square will be 2s. Now you can substitute exponential there. What is the coefficient of the compare? E raised to power minus 80. A will be my minus 1. So you can substitute s is minus 1. Left hand side will be 0 to a e raised to power t square cos of t into dt. What is the answer of this? S square is minus 1. So this is 4. S is equal to minus 1. It's my plus 1. Minus this will be 0 into something is. So this is my 2 raised to power 4. So 8 over 16. 1 over 2 is my right answer of the problem. Now again you can see I can firstly found the Laplace of sine mt. It is m over, again 0 to infinity is there, so I can start with the Laplace. Then what is the rule of this sine mt divided by t? So whenever it's an integration you have to start from this Laplace of this quantity. Fine. Now can you find the integration of this? That is nothing but the tan inverse s over m. So you can substitute from s to infinity. When I substitute infinity is a pi by 2. When I substitute here it is my tan inverse s over m. Now there is no exponential term, so you can substitute s is my 0. So when s is 0, the left hand side is my sine m into t over t dt, which is pi over 2 minus tan inverse 0. So tan inverse 0 is my 0. So the right answer is pi by 2 is the correct answer. Always find whatever the function is there, find the Laplace transformation of this function. Now this is there. So firstly, I can find the Laplace transformation of this whole quantity e raised to power minus at e raised to power minus bt over t. This is my f of t. What is the rule for the divided by polynomial? Is from s to infinity Laplace of this value, fine, into ds. So what is the Laplace of this? From s to infinity, Laplace of the first value will be s plus a, Laplace of second value will be s plus b into ds. There is no need to take the LCM, you can simply integrate them. What is the integration of the first part? ln of s plus a minus ln of s plus b from s to infinity. So that will be ln of s plus a over s plus b from s to infinity. So if I substitute infinity, it's an infinity over infinity form. So that's the L'Hopital rule. So if I differentiate them, it's a 1 over 1. So that is a ln 1 minus ln of s plus a over s plus b. ln 1 will be my 0. So it is minus ln of s plus a s plus b, or I can adjust with negative as a reciprocal of this s plus b over s plus a. Now since I start with the Laplace, so I can substitute, because there is no exponential term appear apart from this, so I can substitute s is my 0. So what is the left hand side is exponential minus a minus b over t, which is come to be ln of b over a is the right answer. So this question somebody can ask you like a proof that, somebody may ask you the proof that, fine. Look at this quantity again. I can start with the Laplace, because the limits are 0 to infinity. Remember student, always whenever the limits are 0 to infinity, only you can apply this rule. Whenever the limits are my say this one, then it is not applicable. So what is that? 6 cos of 4t divided by t. Again it's a division by t, so I have to integrate from 0 to infinity Laplace of the remaining quantity, cos 4t into ds. So what is the Laplace of the cos 6 into t? So that is s over s square plus 36. It is s over s square plus 16 into ds. So what is the integration of this? If I take s square plus 36 is my t, or say y, then 2s ds will be my dy. So this first integration will be dy over 2 divided by y. So that is half ln of y. So I can simply say half ln of s square plus 36. Similarly for this quantity, half ln of s square plus 16 from s to infinity. Half is common, so I can apply the rule of the ln plus 36 divided by l square plus 16 from s to infinity. Now if you substitute as infinity, what is the answer is? Now if I substitute infinity, so it's an infinity over infinity form. I can apply the L'Hopital rule. It's a 2s over 2s, that is a 1. So ln of 1 is my 0 minus half s square plus 36 over s square plus 16. So that minus I can adjust them. It is half ln s square plus 16 s square plus 36. Now its Laplace is over. Now there is no other term. You can substitute s is equal to 0. So this integration is my, this value you can write here, cos 6t minus cos 4t divided by t of dt, which is equal to, I can substitute s is my 0. So this is my 16 over 36. So I can return this is, I can divide it by 4. So 4 over 9, that's a 2 over 3 square. So it is ln of 2 over 3. This square and half will be cancelled out. So the right answer is ln 2 by 3 is the correct answer. Okay, now look at that. Now you can see this integration is start from the 0 to infinity. So I can apply the same rule here. So before that, and again exponential term present. So at the end I can substitute s is equal to 3. So I need to find firstly integration Laplace of this remaining quantity. Fine, this is your target. So what is the rule for, if you remember the rule, what is the rule for the 0 to t of f of t? This, whenever it's from 0 to t, then it is 1 over s Laplace of the remaining quantity. But here it again it's a 0 to t, and whenever it's a 0 to s, you can substitute s as a exponential term. So this is 1 over s Laplace of the remaining quantity. Fine. Now what is the rule for the division by t? It's from s to infinity Laplace of this quantity ds. So now you can find this. What is the Laplace of the sine t? 1 over s square plus 1 of ds. What is the integration of this? That is my tan inverse 1 over a, that's a 1, tan inverse s. So what is that? If I substitute this value, so I can write here, it is 1 over s, infinity will be pi by 2 minus tan inverse 1 of s. Fine. Now this part is over. Now you can substitute, put s is equal to 3. Fine. So the left hand side will be 0 to infinity e raised to power minus 3t of t raised to power 0 sin t over t dt of this. If I substitute s is 3, it is 1 over 3 pi over 2 minus tan inverse 3. That is the answer. Or you can pi over 2 minus is my cot inverse 3 is the right answer of this problem. Again the exponential term present and limits are from 0 to infinity. I can find the Laplace transformation of this quantity. That is a sine square t over t. It is division by t, so it's from s to infinity Laplace of sine square t. So how you can find the Laplace of sine square t? I can write firstly here. So it will be divided by 2, 1 minus cos 2t. So half is outside. So Laplace of 1 is 1 over s. Laplace of this will be s over s square plus 4. So I can substitute this value here. It is from 0 to s to infinity. Half is my outside. Then it is 1 over s over s square plus 4 into ds. So can you integrate them? It is my ln of s. I can multiply and divide it by 2. It is half ln of s square plus 4 from 0s to infinity. So I can take 2 is the LCM. So 1 over 4 is outside. It is my 2 ln s minus ln of s square plus 4 from s to infinity. Let me move this one. Fine. Now it is 1 over 4. So I can apply, this is ln of s square minus this. I can return like of here. Now what is the limit when you substitute infinity? It's an infinity by infinity form. So I apply the L'Hopital rule. So it's a 2s over 2s, that's a 1. ln 1 is my 0. So it is 1 over 4 minus s square over s square plus 4. Fine. Now let me clear this screen here. Now what you can do, this number, so it will be minus, I can adjust them. It is 1 over 4 ln of s square plus 4 over s square. Now you can substitute s is 1. Always I again see, you always compare this exponential part with here. What is my a? A is my 1. So you can substitute s is 1. So the left hand side will be exponential this sine square t divided by t of this. It is s is equal to 1. So it is ln 5 over 4 is the right answer. Again this is the same similar kind of this. Again the exponential term present. I have to firstly evaluate this. It is my this number sine of t. Fine. So it is, what is the Laplace of the sine t is 1 over s square plus 1 of ds. So that is tan inverse s over 1 from s to infinity. If I substitute infinity, it's a pi by 2 and then it's a tan inverse s. Then I can compare this. I have to substitute s is equal to 1. So the left hand side becomes e raised to power minus of t sin t over t. When I substitute 1, it is pi by 2 minus tan inverse 1. Tan inverse 1 will be my pi by 4. So I can substitute here. The answer is pi by 2 is the right answer of this problem. Sorry, pi by 4. I can take 4 is the LCM, 2 pi minus pi, that's a pi minus pi by 4 is the right answer. Okay, again you can see, can you integrate this part without using the Laplace? It is not possible. So how you can start with them? I can simply change x square to be say t. Fine. Then what is my x? X is my root t. What is my dx is half root t into dt. So this integration minus x square of dx, it becomes to be 0 to infinity. Because the limits are my 0 to infinity, I can think about the Laplace transformation. So minus of t half root of t of dt. So I can take half is outside, 0 to t e raised to power minus of t raised to power minus half dt. Now you can, because the exponential term present, you can find the Laplace of this value. What is the Laplace of this? Gamma function of minus half plus 1 over s half. So gamma function of is a half divided by s of this. Gamma function of half is root pi divided by s by root. So I can substitute here. So in this case, what is the Laplace of this quantity? I have to substitute. Put s is equal to, if I compare them, s is my 1. So if I substitute 1, the left hand side becomes my 0 to infinity e raised to power minus of t minus half t. When I substitute 1, it is my root pi. So this answer is my root pi. So the final answer will be half root pi is the required answer of the problem. Okay, again it's a 0 to infinity. Again the exponential term present. So I have to firstly find the Laplace of sine hyperbolic divided by t. So it's a division by t. So I have to integrate from s to infinity sine hyperbolic t. What is the sine hyperbolic t is? 1 over s square minus 1. So what is the integration of this? How you can integrate them? Either you can remember the formula of the 1 over 2 is something. Otherwise you can partial fraction it. S minus 1, s plus 1. So what is the partial fraction of this? S minus 1, s plus 1 of ds. When you substitute 1, it's a half, otherwise minus half. So what is the integration of this component? So first component half is outside, ln of s minus 1 minus half is outside, ln of s plus 1 from s to infinity. It is half is outside, it is s minus 1 over s plus 1 from s to. So when I substitute infinity, it's infinity by infinity form. So that's a ln 1 0 minus half ln of s minus 1 over s plus 1. So half I can adjust them. It is s plus 1 over s minus 1. Then what you can do? You can substitute s is equal to 2. Fine. So the left hand side becomes e raised to power minus of 2t sine hyperbolic t over t of dt, which is, when you substitute 2, it is my ln of 3 divided by 1 is the right answer. Again you can see the exponential term present. So I have to firstly find the Laplace of this number. How you can find that? Because the polynomial term present, it's a minus 1 raised to power 1 first derivative of the remaining quantity. Fine. So it is minus d by ds. What is the Laplace of this? S over s square plus 4. So it is minus s square plus 4 over square is LCM, s square plus 4 into derivative of s is 1 into derivative of this value. So if I take the LCM, it will be my 4 minus s square divided by s square plus 4 whole square. Now I computed this one, so I can substitute, put s is equal to 3. So therefore the left hand side becomes 0 to infinity t e raised to power minus 3 into t cos of 2t of dt is my, when you substitute s is my 3, so 4 minus 9, it is my 9 plus 4 whole square. So that is 169 is the right answer of the problem. You can see that, how you can see this one, because the left hand side, that is you can see about that, this Laplace left hand side becomes my e raised to power minus st into t of this number. Fine. So that's why if I compare this quantity with here, s is my 3. Okay, look at this one. Again the exponential term present and the limits are from 0 to infinity. So I have to find Laplace of t square sine of 2t. So it's a t square. So minus 1 raised to power 2, second derivative of the remaining thing, Laplace of sine 2t. So what is the Laplace of this? Minus 1 square is a positive. So d by ds square. Laplace of this is a over s square plus 4. So I can firstly find the first derivative. The first derivative will be minus 4s over s square plus 4 whole square. Now you can find the second derivative. It is s square plus 4 power 4. S square plus 4 whole square. Derivative of this value will be minus 4, then minus minus plus 4s into derivative of this denominator, s square plus 4 into 2s. Fine. There is no need to simplify it. Now you can substitute, put s is equal to 1. So your left hand side becomes 0 to infinity e raised to power minus t square sine of 2t of dt. There is no need to simplify it. You can substitute the value directly. It's a 5 square 25 into minus 4 plus 4, 2 into s is 1, so it's a 5, 2 into 5, this is into 2 divided by s is 1, so 4 plus 5, 5 raised to power 4. So it is minus 100, it is plus 400 divided by 625. So 300 divided by 625. You can cancel it with that 25. So 25 into 25, 25 into 12. So that is 12 divided by 25 is the right answer of this problem. Now you can see about this. Again the 0 to infinity appears and exponential appears. So this exponential, it means s I can substitute as 1. So I have to firstly find Laplace of the remaining quantity. Remaining value is my here. Fine. So how you can do that? You can see Laplace of the integration is 1 over s of the remaining value, minus 3t e raised to power minus 6t over t. Now what is the rule of the Laplace of the denominator? Integration s to infinity of the remaining thing. So e raised to power minus 3t e raised to power minus 6t into ds. Now 1 over s from s to, what is the Laplace of this value? 1 over s plus 3, 1 over s plus 6 of ds. Now what is the integration of this? So that will be ln of s plus 3 ln of s plus 6 from s to infinity. So this is 1 over s. I can return this number as ln of s plus 3 s plus 6 from s to infinity. When I substitute infinity, is infinity over infinity, that's a 1. So ln 1 is 0. Remember, this infinity is only substituting in this case, not in here. So it is my 0 minus ln of s plus 3 s plus 6. So what is that? It's a 1 over s ln of minus, I can adjust it as here. Now you can substitute the value e, you can put s is my 1. So this value, that is the left hand side, is my this value, which is s is 1. It's a 1 over 1 ln of 7 by 4 is the right answer of this problem. Again you can see here exponential term present. Fine. So it means your target is to find the Laplace of t cube sine of t. So minus 1 raised to power 3 third derivative of Laplace sine t. Fine. So it is a minus third derivative of sine t is s square plus 1. So can you find this? So what is the first derivative of this? It is my minus 2s over s square plus 1. So minus minus I can take it as a positive, or I can see here. So what is the again derivative of this will be s square plus 1 square. So s square plus 1 of minus 2 minus minus plus 2s and of 2s. So this will be minus d by ds of, if you simplify them, it's a 4s square minus plus the 4s square minus the 2s square is a plus 2s square divided by s square plus 1 whole square. Fine. Now it's a minus of 2s square plus 4s square is a 2s. Now you can final one more time derivative. It is s square plus 1 raised to power 4. So it's a s square plus 1 of square into derivative of this, it's a 4s minus 2 plus 2s square derivative of this twice s square plus 1 into 2s. Now there is no need to simplify this. You can put directly s will be 2. Fine. So when you substitute s is equal to 2, left hand side becomes my t cube e raised to power 2t sine of t of dt, which is minus divided by, when s is equal to 2, it's a 4 plus 1 5, it's a 25 into 8 minus s is equal to 2 is a 4 2 are 8, 8 minus 2 6 into 2, 4 plus 1 5 and 2 into 2 4 divided by 4 plus 1 5 raised to power 4. So now you can simplify it, you will get the right answer. So that will be my 200. It is my 20, 12 into 20, that's a 240 divided by 625. So that is a 40 divided by 625 is the right answer of this problem. You can cancel it with the respect to the 5, 85 and 125. So the answer is 8 over 125 is the correct answer. Again you can see the exponential term present, and again the again the integration is from 0 to infinity. So I can start from this value. So that means minus 1 of first derivative Laplace of the sine t. What is the Laplace of the sine t? Is s square plus 9. So can you find the Laplace of this? Oh sorry, derivative of this? It will be minus 6s over s square plus 9 square. Fine. So this is my 6s over s square plus 9 whole square. Then you can substitute s will be my 2. So put s equal to 2. The left hand side becomes my e raised to power minus 2t sine of 3t, which is equal to s equal to 2 is a 12 minus divided by s equal to 4. 4 plus 9 is 13 square. So that is 12 over 169 is my right answer of the problem. Again you can see again the exponential term present, 0 to infinity. You can find the Laplace of this number, minus 1 raised to power 1 derivative of Laplace of the sine s square plus 1. So it's the first time derivative. So what is the first time derivative? S square plus 1 whole square. So s square plus 1 into 0, 1 of is 2s. So that will be 2s over s square plus 1 whole square. Now you can substitute, s will be my 2. Fine. So what is your right answer? 0 to infinity t e raised to power minus sine of t of dt, which is 4 divided by 4 plus 1, 5 square, that is 4 over 25 is the answer of this problem. So I hope you can simply learn the various tricks to solve them. You can see like, share and comment on my video. Best of luck students. Happy learning.